Welcome to Coder Station.
Hey guys, welcome to Coder Station. In today's video, we are going to see what are the bitwise operators in Python. So, bitwise operators are used to play with the bits, that is perform bit operation, that is AND operation, or NOT, XOR operation, right shift operation and left shift operation. So we will see this all the operators in detail. So first we will go with bitwise AND operator. So what AND operator says that the if both the operands are 1, then only the result is 1, otherwise the result is 0. For example, I have stored I have taken two variables a and b, and I have stored value as 2 and 3 in it, which are decimal values, and its binary representation is 010 for 2 and 00011 for 3. So what will happen here, we will perform an AND operation. According to AND operation, we will start from left hand side. So according to AND operation, first first bits are 0 and 0. So this 0 and 0 will become 0 obviously. 1 and 1. Here you can see that 2 has 1 and 3 has 1 on the second position. So 1 and 1 becomes 1 in AND operator. So we will print here 1, and 0 and 1 on the third position will become 0, because AND operator says that if both the operands have 1 and 1, then only the result will be 1, otherwise it will be 0. After running the program, this will give us an output in decimal, and in decimal this value is denoted as 2. So we will get output as 2. So let us print the program. So after running the program, we are getting this output as 2. Ignore this part. We are getting the output as 2. Similarly, now we will see OR operator. What OR operator suggests is that um, the result of the bits are 1 if any of the operand is having 1, otherwise 0. Simply in this case, I'll say that only 0 and 0 in this OR operator will become 0. Rest all operands having 1 at any position, first, second will become 1. So we will perform an OR operation over here. For performing OR operator, we will use the symbol of OR operator, which is in my keyboard located over oblique symbol. And after performing OR operation, our output will become as like this, because OR operator says that 0 and 0 are 0, so we have written here 0. 1 and 1 is already 1, so we have written it 1, and 0 and 1 is also 1 in OR operator, so we have written it as 1. So this number becomes 3 in decimal form. So after running the program, we will get the output as 3. When we run the program, we are getting the outputs as 3. Similarly, the next operator is NOT operator. What NOT operator does, that it inverts the individual bits of any variable. For example, we will invert b in this case. After inversion, what happens is that the number at one number written as 1 will invert and become 0, and this will become, the zeros will become 1, and after printing we are getting the output as -4. Similarly, in XOR operator, it results the bit as 1 is any of the operand is 1 but not both. What happens in this operator is that it prints output just like an OR operator, but in OR operator 1 and 1 also this also gives you result as 1, but in this, if both the bits are same, that is 1 and 1, you will get the output as 0. So we will get the output here as 0 0 1. Then when you try to run the program, according to this number, it is a decimal number 1 in bitwise system. So when you try to print a XOR b, then we will get the output as 1 as I mentioned. Similarly, next operator is a bitwise right shift operator and bitwise left shift operator. What this operator does is that is moves the ones in the bit to the right hand side and the left hand side accordingly. Let us take the operator as A and we will shift it towards its right by 1 bit. So if this one into shifts to the right, that is this one, if it will shift to the right, then the output we will get as 0 0 1, and the this is nothing but 1 as I mentioned before in the binary system. So we are getting the output as 1. Similarly, if we do perform left shift to 1, then according to this condition, the 1 will move on left hand side and zeros will remain as it is. And if you try to run program, the output is 4 because this is denoted as 4 in binary to decimal system. Convergence or doing conversion from binary to decimal or decimal to binary is very easy. First you write 4. See, you will write 1, 2, 4, and 8. For example, if you want to print 1, then it will be 0, 0, 0, 1. Similarly, for 2, it will be 0, 0, 1, 2. You have to make a pair of the values such that you will get the output, that is resultant number, very fast. For example, if you want to make a number, let us say 13. So, in the faster way, 13 can be made as 8 plus 4, that is 12. So, we don't need 2 over here to make 13. So, we will make it as 0 and we will print it as 1. So 8 plus 4 is 12 and 12 plus 1 is 13. So these are the binary systems you should know while performing conversions, and you must know it before doing bitwise operators. To start with the bitwise operators, I'll first suggest to go and study the binary system because it is much easy and you will understand it faster. I hope you liked this video. Thank you for watching my video. Stay tuned for the next video, and for any of the queries, use the comment box. I'll revert that query if you have any. Thank you so much for watching this video.